session, yes, or next few sessions?
To learn how to draw camera profile.
Okay. Hello. I shared one tab. Is it visible to you?
Yes.
अरे आवाज इतना ही का? I'm audible? What about induction motor? Okay, like that sound is coming. Okay, okay. Okay, now I'm audible.
Yes,
Yes, sir.
Okay, okay, okay. But if again it happens, then tell me, inform me, please.
Yes, sir.
Because actually I want to save time by considering this, and it will be, I think that videos are better to explain. I will explain everything. Just already animations are there, so it is better to explain with that. But okay, we'll try whether it is working or not. And if it will work, then it is better to for your understanding. Okay. Okay, I'm sharing now. Just give me feedback when it is visible to you, and if any sound, please. Yes, is it visible now?
Yes, sir.
Okay. Okay. No any sound now?
No, sir.
No,
Okay.
sir.
Good. Better. Now see how to draw cam profile. I already told you. All of you try to listen carefully what I'm discussing with you. It is very important topic and it's scoring topic also. Just we need to understand procedure to draw it. Before drawing cam profile, what essentially is you must know which types of follower motions are possible. In a numerical, one type of follower motion is given. Now means during rise, type of follower motion is given, and during return again, another type of follower motion is given. So during rise and return, you have to check which type of follower motion is. It may be possible that during both strokes, the follower motion is similar. Second thing means first we have to check which type of follower motion is. Second thing we have to check whether the follower is radial or offset. And third one, we have to check how cam rotates. Step by step, I'll explain with you. So I think it is clear what you have to check first before drawing a cam profile. Please interact with me so that it is better for me to explain. What you have to check first in a numerical? Hello?
First, what type of motion, then what type of cam profile we have seen, either it is radial or offset, and then how cam rotates.
Very good. These three things we need to check before drawing cam profile. If you understand these three things, then it is very easy to draw a right cam profile. I'm saying right cam profile because students will draw everything, but it is wrong. Means whatever you have to draw, what is expected, it is not drawn. Okay, now see. So this data is this kind of data is given to you. You have to draw a cam profile in case of knife edge follower using following data. What data given is minimum radius of cam is 5 cm. Outstroke. Outstroke means what do you mean by outstroke? See, basically we assume that the follower is having rise, dwell, and return. Rise means follower moves outward. Follower moves upward, or we can say outward. That's rise stroke is sometimes called as a outstroke. So outstroke is given. How much that and outstroke is there when cam rotates through 120 degree. We know that when cam rotates, follower will reciprocate. So for 120 degree, when cam rotates through 120 degree, the follower rises or follower moves out. So angle of outstroke theta O is 120 degree and it is given with SHM. So here you can check angle is given and which type of motion it is, simple harmonic motion. So this we have to check. Means we have to check how much theta O is, how much theta D is, and how much theta R is. What is theta O, theta D, theta R? Theta O is angle of outstroke, theta D is dwell angle, and theta R is angle during return stroke. So here theta O is 120 degree and it is with SHM. For dwell period, there is no motion as the follower is stationary. Return stroke is given, again it is 120 degree with SHM. So both motions, that is rise and return, occurs with SHM motion, simple harmonic motion. You can check one more thing here. So what next one is given? Rise angle given, return angle given, dwell angle given, both motions are SHM. So we come to know which type of motion it is. And to draw cam profile, we must know what is the radius of the cam, basic radius of the cam, base radius of the cam, RB we can say, base circle radius, that is 5 cm given. So one of the given important data, that is 5 cm RB. Then dwell for the remaining period of the cam rotation. It is given first follower rises, there is dwell, followed by return. After return stroke, again there is dwell. So it is essential to understand how the follower motion is, what sequence is. So first there is rise, dwell, return, and then again dwell. Stroke or lift of the follower is given. How much follower rises? It is 6 cm. So after this data, we need to draw, the first step in drawing cam profile is to draw displacement diagram. And for drawing displacement diagram, we have to write given data. So what is given here? We come to know theta O is 120 degree. In bracket, we have to write SHM. So what is theta O? Yes, what is theta O? Yes.
60 degree.
Theta O is 120 degree. But what is theta O? Meaning of this theta O?
Outstroke.
Angle turned by cam during outstroke, or also we can call it as angle turned by cam during rise. Then during dwell, angle turned by cam during dwell period is 60 degree, while angle turned by cam during return stroke is 120 degree. That we have tried here. And the remaining angle means total rotation is 360 degree. So for 120 degree it rises, 60 degree there is dwell, and next 120 degree there is return, while remaining angle is again dwell period. Means follower rises, then there will be a stationary follower, then return, and again dwell. Dwell means follower does not move. Forward motion is stationary. So again there will be a return stroke for a 60 degree. Sorry, remaining period is dwell. Follower displacement is 6 centimeter. All these are given data. So first, after this given data, we have to select suitable scale. In first step, I write on given data. In second step, you have to select suitable scale. And the scale for this one is, you can check here. We have to draw x and y axis for a displacement diagram. So for drawing displacement diagram, the scale taken here is, for y axis, we consider 1 centimeter is equal to 1 centimeter. And you know that on y axis, we are going to draw displacement of follower. On x axis, we have to draw cam rotation. And for that, scale we selected is 1 centimeter is equal to 20 degree. You can select suitable scale so that you can draw these angles. Now it is known to you, if one on x axis, if 1 centimeter is equal to 20 degree scale, so for 120 degree drawing, how much centimeter it is? Theta O, first stroke is 120, means how much centimeter it is? For that, scale is 20 degree, 1 centimeter is equal to 20 degree. Therefore, 120 divided by 20 is equal to 6 centimeter. Means this 120 degree of outstroke is represented on displacement diagram by 6 centimeter. Similarly, divide the angle by 20 degree for dwell as well as return stroke, we get distance in centimeter during which rise, dwell, and return occurs. So this distance you have to find out by dividing scale, that is 20 degree, to the angle given. First step is clear. We have to consider suitable scale for drawing x and y axis. Any doubt here in selection of scale? Yes? Hello?
No doubt, sir.
Okay. Now see, with the help of this scale, you have to draw your displacement diagram. And for drawing displacement diagram, it is known to you on y-axis what to draw. What y-axis represented in displacement diagram? Yes. What y-axis represents?
Place the follower,
Follower displacement. And x-axis?
cam rotation.
Okay, so that we have to draw. Already we selected scale. So the scale is 1 centimeter, 20 degree, 1 centimeter, 1 centimeter for y-axis. And accordingly, we find out its scale distance. That is, even though theta is 120 degree, but on actual diagram, I have to represent same by 6 centimeter by considering our scale. Then 3 centimeter for dwell, and theta r is 6 centimeter, that is return stroke. Dwell period, again, next dwell period we will not consider. Okay, so likewise, we can draw first x-axis and y-axis. You can see we have drawn one line first representing x-axis, then another line representing y-axis. Here we can draw a rectangle for drawing a displacement diagram. So next we have to complete the rectangle. Now tell me how much height of the rectangle is. Yes, how much height of the rectangle is? This height I am saying, how much it is? Yes,
6
anyone?
centimeter.
So represent, as it is known to you, the rectangle y-axis represent follower displacement. And all of you know, in a given data, you might note down that the follower displacement is 6 centimeter. So here this y-axis or this height represent follower displacement. And on x-axis, you have to select now scale. See, it is given first theta O is 120 degree. So sequence you have to draw here from given data. First there is dual outstroke, angle is 120 degree. Dual followed by dual and then return. How much angle for dual is, for outstroke is 120. For dual it is 60 degree. Return is 120 degree. But we say select one suitable scale, and from our scale, this 120 degree is equal to how much centimeter? 6 centimeter. Because what scale we prefer here? 1 centimeter is equal to 20 degree. So 120 divided by 20, that is 6 centimeter. So I have drawn here 6 centimeter. With the actual scale, we have to draw 6 centimeter. Then how much this will be dual distance? Angle is
3 centimeter.
3 centimeter. For return, how much it is?
6.
And remaining, there is no need to take scale for remaining as the angle is not mentioned. Actually, it is also given here. We can find out that it is 60, I think. So 60 divided by 20, so it is again 3 centimeter. So rise, this portion is for rise. This arrow is visible, what I am showing?
Yes, sir.
Okay. So this one is for rise, then dwell, return, and after return again, there is dwell.
Yes, sir.
Okay. So this is your first step. Draw x-axis, draw y-axis, complete this rectangle. And here, what this vertical lines represents in between? What this line represents? Tell me. It is end of the rise stroke. See, follower rises from this point to this point. So the follower rise will start at O point, and then at 6 point it will end. Now, what this numbers represents? 1, 2, 3, 4, 5, 6. Here, remember, we have to divide that rise and return into equal number of parts. So I divide this rise into equal number of parts. We can say the numbering is start from 0, 0, 1, 2, 3, 4, 5, 6. 6 number of parts I divide. So return, as both rise as well as return are both having SHM, when both motions are same, means rise and return both is same, then divide into equal number of parts. Listen it carefully what I am saying. When both rise and return is same, motion is same, both SHM, then you can divide into same parts. If not, then it is not essential to divide both, that is rise and return, into equal parts. You may divide into unequal parts. Means here it is 6, there may be 8 or 10. As both are SHM, I have to divide rise and return into equal number of parts. As I divide into 6 parts rise, so for return also I have to make 6 parts only. Now after 6, you observe, actually they give a name 7, 8, 9, but it is not the actual name. Here we have to go again 6. Means here it is 6. At the end of dual again it is 6 because follower is stationary. Then it is 6, 7, 8, 9, 10, 11 and 12. So 12 parts. 6 to 12 again. Here they are showing only scale here. So the first step is clear, how to draw this rectangle by taking a suitable scale, and how to mark rise, dual and return. Is it clear?
Yes, sir.
Okay.
Yes, sir.
Okay. Now see next. Now after this, you have to mark these divisions. Remember, all this work will be done by very faint lines. So here it is again. So I divide this rise period into 6 parts and return also into 6 parts. Clear first step? After scaling, divide rise. You can see now here. So theta O is 120 degree. I divide theta O into 6 parts. There is no need to divide dual period. Don't divide dual period. But divide return also into 6 parts. Why I divide this both into equal parts?
Motion is same.
Yes. Whenever motion during rise and return is same, then divide both into equal parts. If not same, there is no need to divide into equal. You may divide, but it is not essential to divide into equal parts. Okay. After that, we have to give some namings. Likewise, you can see now. So these are 6 parts. Dual period, and then return stroke. Okay. The rest of the period is again dual period. No need to divide dual period. Now you can see, after marking a vertical lines through this, what we need to do is we have to draw this semicircle here. You know how much this displacement is? On y-axis, how much it is? Height of the y-axis, how much it is?
6 centimeter.
So follower displacement is given in the numerical. Check how much follower displacement is. As the follower displacement is 6 centimeter, I have to draw height of this y-axis is equal to 6 centimeter. Now, if, listen carefully, if the motion is SHM, if motion is SHM, then how to draw displacement diagram, that I am discussing now. Remember, this procedure is only for SHM. So when motion is SHM, then divide this actually after on y-axis, draw a semicircle of a diameter equal to follower displacement. I'm saying draw a semicircle with diameter is equal to follower displacement. In this case, it is 6 centimeter. So half of the height as a center, let's say 3 centimeter in this case. Take this point as center and draw a semicircle of diameter is equal to 6 centimeter. After that, so yes, after this, I have to divide this semicircle into 6 equal parts. My question is why 6 parts now? I'm going to divide this semicircle into 6 parts only. Why 6 parts? Because I divide this cam angle also into 6 parts. As the motion is SHM for rise and return, I divide rise also into 6 parts and return also into 6 parts. And hence, divide this y-axis also, not y-axis I'm saying, but divide this circle, that is 120-degree semicircle, into 6 parts. If we divide this rise into 8 parts, return into 8 parts, then also I have to divide this circle into how many parts? Semicircle into how many parts?
8.
8 parts. So number of divisions on a semicircle is equal to number of divisions on x-axis for rise and return. Clear?
Yes, sir.
Okay. So divide this semicircle into 6 number of parts. And you know the angle of semicircle is 180 degree. And hence 180 divided by 6. So each angle is equal to how much? One division is equal to? How much it is? 30 degree. So divide this by using a compass or angle measurement scale. So these are the 6 parts, 30 degree, 30 degree. Join them by faint lines. Okay, you can see this naming now. 0 to 6 and again 0 to 6. 0, 1, 2, 3, 4, 5, 6. Next step. Observe this step, what we are doing. See, I consider 0 to 6 here for rise. So on this 0 to 6, I give a name like this: 0, 1, 2, 3, 4, 5, 6. That's why number of parts divisions must be same. After that, I will take projections from this 1, 2, 3. That is from, I have to project this point on semicircle to a y-axis. Or you can say horizontal projections I have to take. Up to where I have to take projections. When I draw line through 1, I have to draw the projection up to vertical through 1. Vertical projection through 1. Similarly, a horizontal line up to vertical projection through 2, then up to 3, up to 4, 5 and 6 it is here. So clear how up to where we have to take projections from this 1, 2, 3, 4, 5, 6? Hello?
Yes, sir.
Up to where? Yes, anyone? Up to where to take projections? कुठपर्यंत घ्यायचे प्रोजेक्शन ते 0, 1, 2, 3, 4, 5, 6. Up to where? Up to which line?
Corresponding vertical line.
Very good. Corresponding vertical projections. When I have to draw projection through 2, I will take it up to projection, vertical projection through 2. Likewise, we can take projections. Now you can observe it. So projection through 2, through 3 up to now. You can see up to 3, up to it is up to here. So up to here, then up to 4, this line, vertical line. Okay. Next, through 4, 5, and finally it is 6. Now get these points. Okay. So get these points by these projections. And now join these points by a smooth curve. We get your displacement curve for a SHM. Is it clear?
Yes, sir.
Yes. Is it clear how to draw a displacement diagram for simple harmonic motion? When motion is simple harmonic motion?
Yes, sir.
Okay. Now see, during rise I follow this motion. How to draw for dwell now? Sorry. Whatever dwell period, it is stationary from here to here. For return, actually we can take that as the rise and return is same motion. And hence, I can take directly projections here. So we know this point. On 1, project it. Now tell me, which will be corresponding line of 1 here? Up to where I can project this point? On which line I have to consider this point?
11.
11. So this point will be here on 11. Then this point will be up to 10. Then up to 9, 8, 7. Draw corresponding point directly by projecting this. You can see. Actually, we can take this projection throughout. So this projection through 1 will corresponding to 1 and 11. 2 corresponding to 2 and, yes, this projection up to where? 2 and 10.
10.
3 and 9.
9.
4 and, yes,
8.
and 5 and 7. Likewise, we can project. So you can see now how it is projected now for the next part. That is written. It will happen only when both rise and return with same motion. If the motion is different, means for uniform rise with SHM and return with some other, then that part will be different. The procedure will be different. I will discuss in next numericals. So here we project one point, first point up to 11. You can check that point. Next, up to 10, projection through 3 up to 9, 4 up to 8, through 5 up to 7, and the last point, that is 6. Join them by smooth curve. This is curve for a return stroke as well as dwell period. So this is your complete graph for a simple harmonic motion during rise and return, and for dwell period it is stationary. After this, next step to draw is nothing but, next step is to draw a cam profile. So while drawing cam profile, first thing I have to check is which type of follower it is. So for drawing follower motion, displacement diagram, you have to check which type of follower motion is. But for drawing cam profile, what I have to check is which type of follower it is. Whether it is knife edge follower, roller follower, oscillating follower, or flat face follower. Now which follower is given here in this case?
Knife edge.
Knife edge follower. Therefore, procedure for drawing knife edge follower cam, that is cam profile when the follower is knife edge, is different. Okay. So for knife edge follower, the follower is knife edge follower. Second thing you have to check is, means I check which type of follower. I come to know it is knife edge follower. Second thing I have to check whether it is radial or offset. So which type of follower is given in this case? In the given data. So we have to check given data carefully. It is given the follower is a, yes,
Knife edge.
I think knife edge, but radial or offset, that we have to check. I think offset is given, but okay, we'll check now. So we have to check whether it is knife edge, sorry, it is radial or offset. If offset, then how? If radial, then how to draw. Okay. And one more thing we have to check, how cam rotates. It is given the cam rotates clockwise. If cam rotates clockwise, actually there is one principle called the principle of kinematic inversion. But we assume here the cam is hold stationary, cam is held stationary, and follower is rotated around the cam. Now, how to rotate the follower? Actually, in actual practice, cam rotates and follower reciprocates. But for drawing cam profile, what we assume, the cam is stationary and the follower is rotated around the cam. Now, how to rotate the cam follower? If it is given cam rotates clockwise, then rotate the follower in opposite direction. So in the problem, it is given the cam rotates clockwise, and hence I will rotate follower around the cam in anti-clockwise direction. That's why cam rotation is very important. If as the cam rotates clockwise here, I will rotate it in opposite direction. I will rotate follower in opposite, means in anti-clockwise direction. Hence, from starting point, let's say this one is your starting point, initial point. Here this follower is in contact. From this point, divide this circle in an anti-clockwise manner. Now, why anti-clockwise? Tell me. Why anti-clockwise? Why to divide in anti-clockwise sense? Why not clockwise? Yes? Anyone? Because cam rotates clockwise. It is given in the numerical. It is given cam rotates clockwise, and hence divided anti-clockwise sense. Clear? Hello? Are आवाज येतो का नहीं?
Yes, sir.
So reply it, please. So as the cam rotates clockwise, follower we have to divide this cam angle we have to divide in anti-clockwise way. That is important. Next, now how many parts I have to divide? Check follower diagram, displacement diagram. First there is theta O. How much degree theta O? 120 degree. Dwell for 60 degree. And again return for 60. So divide this cam. Actually, how much this circle radius is? It is equal to base circle radius. It is given 5 centimeters. So I draw a circle with a 5 centimeter radius. is equal to base circle radius of the cam. It is given in the numerical. Check how much base circle radius is given. For that radius, draw a circle. After drawing that circle, check how cam rotates. As cam rotates clockwise, I have to divide in anti-clockwise manner into the given angles. So first mark 60 degree. Sorry, how much it is given? We have to check 120 degree, then 60 and 120. So mark that angles here. You can check now. So we have to draw, depends upon how cam rotates. So after dividing this, so you can check here how many parts it is taken, how much angle is taken here. 0 to 120. Why 120 only? Yes. Why 120?
Max 120 आहे.
You have to check how much theta O is. So first mark theta O is equal to 120, not max 120. Theta O is 120. Hence mark 120. Understand? You have to mark. You have to draw the same angles here. 120, then theta D 60 degree, and again theta R 120 degree. So mark 120, 60, and 120 as it is given. So mark accordingly what is given data and divide them into how many parts? So first I mark 120 degree, but how many parts I divide here into 6 parts only. Why 6? Because displacement diagram is also you have to divide by 6 parts. So mark 120 degree and divide into 6 parts. EP here 8 parts, divide here 8 parts. So similar divisions you have to make. First step clear. Mark theta O 120 in anti-clockwise direction and divide into 6 parts. Next, mark theta D. How much theta D is? 60. So here we divide into equal parts. That is each part is equal to 120 degree. Sorry, each part is equal to 20 degree. Now mark 60, next 60 angle here. This represents your dwell period. Now next, from this dwell, you have to mark return stroke. How much return stroke is given? Angle of return?
120.
So mark 120, and so this one is this angle. You can check here from here to here it is 120, and again divide into 6 parts. Why 6? Because here also we take 6 parts. Now give naming. This naming is same as displacement diagram. You can check here. Theta O 0 to 6. Dwell period remains same. 6 here, start also 6, and 6 to 12 as same here. Is it clear up to here? Hello. Are you समझ लेगा how to draw this cam profile?
Yes, sir.
Draw a circle of radius is equal to 25 mm. Mark theta O, divide into equal part as displacement diagram. Mark theta D, no need to divide dwell period. Mark theta R, divide into again same as displacement diagram. Next, after this, very simple. You can check directly now here. After getting this, what next step is? This follower now at 0, it is at 0 position. See, when it is and displacement diagram it is here, the follower is at this position. This is knife edge follower. But when it is at position 1, then it is follower is at A. So this distance 1A I have to consider. Then, so this distance 1A I have to mark at this point, 1A here. Similarly, 2B I have to mark on 2B on line through 2, and similarly 3C, then 4D I have to mark, and so on. So we are taking distance is equal to 1 to A. Here it is, you can check the scale. You can take with the compass also. Direct distance is 1 to A and mark it here. Now they are using scale here. So 1 to A, same distance I have to mark. 1A, same distance on follower diagram. 1A, then 2B. From displacement diagram I have to copy on the cam profile here 2B distance, 2 to B. You can take it compass also instead of scale, it is easier. And draw an arc, or you can draw with scale also on a line through 2B, and so on. We can go on marking like 3C. Here it is 3C. Draw on a line through 3. Okay, and so on. We will continue. 4D, then 5E. Is it clear how which distance you are marking? समजते का डिस्टन्स कोणता मार्क केला समजते का?
Yes, sir.
Distance from displacement diagram. And
Yes,
go on
sir.
repeating up to F, G, H, I, J, K, L. We get their corresponding points. And once you get these points, you can check here. First point and end point is at the where these 2 points are. The first point is O point. It is at the when the follower is stationary at the start. End is at 12. You can see follower returns. Follower rises, dwell, and return at L. Here also it is 0. Displacement is 0. Here also it is 0. Then join these points by smooth curve. That one is nothing but your cam profile. So after getting these points A, B, C, D, E, F, G, H, I, J, K, L, we have to join these points by smooth curve. So this curve, through these points we have to join. Okay, procedure is clear? Are समझ it is just simple problem based on knife edge follower with a simple harmonic motion. This curve. This is procedure to draw a cam profile when the follower is knife edge, radial, and the motion is simple harmonic motion. Is it clear?
Yes, sir.
Okay.
Yes, sir.
If any doubt, please ask. Yes, please. If any doubt, ask.